Good afternoon. I want us to look at similar figures and how we can resolve problems that involve similar figures. First of all, we try to understand what really happens when you have similar figures. So let's say I have two buckets that are similar. The first one has a height which is A centimeters, and then the second one, the height is B centimeters. So we can do ratios for this. The height of the smaller one, the smaller bucket, to that of the larger bucket. So we can say if this one is A and then that one has B as height, it could be the radii where you have the radius here and the radius there, you can still use them. For as long as those are lengths, they still serve the same purpose. So we can say A to B. Now, we can write this one as A to B. Now, this one is simply the ratio of their sides. Let me say side ratios. Side ratio. So the ratio of their sides is simply A to B. In case you want to know the ratio for their volumes, the volume ratios, or before volume, maybe we talk about area. Area ratio coming from this, we simply say area ratio is equal to, you just square this one. So we talk about A squared to B squared. Whatever it gives you after you evaluate, those will be the ratios or the ratio for their areas. And then the volume ratio, if the side ratios are A to B, the volume ratio will simply be A to the power 3 to B to the power 3. So this is how it actually works. Now there are times when you can be given, let's say, the volume ratio, and then they want you to find the area or the surface area of the base or something, given the surface area of another similar figure. So what we can do, if we are given volume ratios, our volume ratio, in this case we are talking about A to the power 3 to B to the power 3. So if we want to find the area ratio, first of all, we need to find the side ratios. And for us to find the side ratios, what you do is you just take the cube root of this. So we can say the cube root of this one to the cube root of this volume ratio, like this. And the cube root of this is simply A, then the cube root of that one is B. And after you found this one, then you can now go to your area ratio. So we can simply say area ratio. Now that we have the side ratios, just exactly what we did here. So you just square the side ratios. You now say A squared and then B squared, like that. The same thing in case you are given the area ratio, then they want you to find the volume of maybe one bucket given the volume of the other. The area ratios are converted to the side ratios by simply taking their square roots, and then from there you can raise them to power 3 and you will have the figures to use. So maybe just in case where we had, let's say here, if this is 2 centimeters, and then here let's say we have 3 centimeters. So in this case, if we want to find, let's say, the ratios for their areas as well as their volumes, what we can simply do is we'll say the side ratio from the height. It can even be the radius. Side ratio, that's 2 to 3. So the area ratio will simply be squaring this one. So we'll say 2 squared to 3 squared, and that gives us 2 squared is 4, and this other one is 9. So that's the meaning where we had a squared, b squared. In case a is 2 and the like, it can come out like this. Then we can use it to find the area given one area. And then the volume ratio is the same thing. So our volume ratio will simply be, for volume, it's in 3 dimensions. So we'll say 2 to the power 3 to 3 to the power 3. And that gives us 8 to 27. So this is the ratio for their volumes. In our next lesson, we will just look at examples of questions that come in the ECZ exam. Thank you for watching.